Hi, my name's Craig Simon. I'm a Senior Solutions Architect with AWS. Today, I'm going to spend a few minutes walking you through a demonstration of a product that we released called AWS Verified Access, or AVA. Now, what is AVA? AVA is a zero trust service. So it allows us to securely deploy applications, HTML-based applications, to the internet without having to store them inside of a secure enclave and then provide VPN access back into this enclave. Instead, we can place a public endpoint directly on the internet, but we can protect and secure that endpoint so that only those users that we want access to the application can gain it. And we can control at a very precise level what each user can do to that application. All accesses, both approved and disallowed, are logged, so I have an entire log trail around all of the application accesses. And then I can securely configure AVA in such a way that I can use another system called RAM, or Resource Access Manager, to share my secure configuration. So most of the time, what I might want to do is I might want my AppSec or my centralized security team to securely configure the AVA service. Then they'll share those AVA groups off to application teams. So those application teams are able to then deploy those applications and use those endpoints that I've created, but I'm able to enforce policy, and I'm able to make sure that the security constraints that I want to apply to these endpoints is in place, even though another team is responsible for actually placing their application there. So I'd like to take just a couple of minutes to address a question which we hear from customers relatively often, which is what's the best way for me to be able to scale AVA in my organization? And I've talked about it to this point, but I really want to go ahead and address that specifically. It's the combination of AVA and RAM that allows you to very easily centrally manage AVA and then enforce and push that configuration down onto the application teams. So using AVA, a central security team can configure their AVA instance. They can configure the user and device trust providers. They can build policies, apply them to the underlying groups, and ensure that only certain groups, certain people are able to connect to the endpoints. Then using RAM, they can push that configuration down to the application development teams. Now that configuration will be enforced because the underlying configuration for AVA is done at that account level, at the central level. So all the policies, all the trust providers, all of the other limits, logging configuration, and everything that that central team places will be enforced by those application teams using that, so you can ensure that those application teams are functioning as you want them to. But again, that centralized security team doesn't have to manage the applications, manage the deployment, and everything else. They get to go ahead and have those application teams manage that. But they do it in a way that is enforced by that central team. Let's take a look at the architecture so you can see what I built for this demo. So this is the architecture for the demo that I've created. Let me walk you through this. First, we're using two AWS accounts. At the top, we've got the AVA sharing account. This is the account that's going to be centrally configured by your security team, and then that configuration will be pushed and shared to the one or more AVA consuming accounts. Now, in the AVA sharing account, what configuration is required in order to get this set up? Just a few bits and pieces, actually. The first thing we need to do is create ourselves a verified access instance. That's really just a container for all the configuration we're going to apply. Once that's in place, then we want to set up at least one trust provider. We have two types. We've got user trust providers, we have device trust providers. User trust providers utilize OIDC, or the OpenID Connect protocol, in order to go ahead and federate against either an internal IDP like AWS IAM Identity Center or an external IDP like Okta or PingID as examples. And that allows us to have your user and group configuration in these external IDPs, and then we can federate our authentication against those. The second type of trust provider is a device trust provider. Currently, we support Jamf and CrowdStrike. This gives us the ability to gain posture information from the device that's making the access. So I can take user trust provider information, I can take device trust provider information, and I can combine those into a policy. And that policy will very easily dictate what I will allow and what I won't allow. And that policy is applied right over here inside this verified access group. I then share, utilizing AWS Resource Access Manager, or RAM, I share that verified access group to one or more consuming accounts. Now, from the consuming accounts, what might they want to go and put in place as far as infrastructure? Probably a few things. From the beginning, we'll want some external DNS and we'll want some external TLS certificates. So Amazon Route 53, I can configure all of my external DNS. In this case, I've got sales.myexample.me and hr.myexample.me, the two external endpoints that I've created. Now, with the certificate manager, I can get free TLS certificates so that I can make sure that all of my connections are fully HTTPS and all of the certificate chains are valid and all that certificates are valid and good for the web browsers that connect. So external DNS and external certificates. The next thing that I would probably like to have in place would be an application. So in this case, I have an EC2 autoscale group that's been front-ended by an application load balancer. So that's how the application is being hosted. Once all this is in place, then I just need to take that verified access group that was shared to this account and then create my endpoints. So I've created hr.myexample.me and sales.myexample.me as endpoints within Ava that utilize all of this infrastructure that's already been set up for here. Let me show you how this works and looks inside the AWS console. Okay, here I am inside the AWS console. And first, I'm just going to go over to VPC because this is where all the Ava configuration is actually created. On the left-hand side, scroll down the menu here to AWS Verified Access, and then we can actually take a look at the configuration that I've got in place here. The first is very simply, as I said, just the Verified Access instance. So inside of here, I can go and I can look through all the configuration that's been placed inside this. I can see the groups that I've created. I can see the trust providers that I've set up. In this case, I've set up a single trust provider that is just talking to AWS Identity Center as my IDP. So this is what I'm performing my authentications against. My login configuration is actually a big part of this whole thing. Let me take a moment just to talk about this really quickly. I've got 3 different login destinations that can be configured. I can configure a destination for S3, directly to S3. I can configure a CloudWatch destination, or I can configure an Amazon Kinesis Firehose destination. What I've done here is I've set this up to use CloudWatch because that's where I'd like my logs to actually land. Now, when I create or update my configuration, a few things I want to call out really quickly. You'll notice that over here under the log version, there's actually 2, and both of them are OCSF. What is OCSF? If you're not familiar with this yet, this is the Open Cybersecurity Framework, and it is a industry standard normalization format. That is a JSON object that AWS and a number of other vendors have really gotten behind as a way to create a big, great JSON object that contains all of our log data and not have to regress back to log lines, which are very difficult to parse and really understand what's being told. So I can choose which version of the OCSF release or format I'd like to use. I can also choose to include my trust context, and this is actually a great one because what this will tell you is this will give you the information back from your user and device trust providers so that you can see what the return data was based on the context of the request that the actual web browser made. So if you're looking for, if you're having issues with authentication or policies aren't being read or actioned on like you think they should, absolutely and turn this on, and that is a great debugging tool. And then as I said, in this case, I just want to deliver to CloudWatch logs. I choose my log group. As well, I can turn it on to enable S3 and or Kinesis Firehose, which I have not done. The last thing inside of my verified access instance that I can do is an integration. And currently, the only integration is integration with AWS WAF. So I can set up a web ACL to further protect my public endpoints with AWS WAF. Now that I've got my verified access instance, let's go look at our trust providers. And I'm just going to move over here to verified access trust provider. And then I'll click on this. And this is just pointing directly back to my identity center. So all of my users and my groups in identity center will be available for use as this identity trust provider. And I'll show you how that works in just a second. The last piece of configuration I've done here is the groups. And so in both of these groups, what I've done is I've simply created the group, and then I've applied a policy, and that policy is done here in what's called the Cedar language. This is a language that Amazon has created and open sourced, and it's a policy language that very easily allows me to find parts of HTTP context, returned data. I can index into JSON objects that are being returned by my IDP, so I can find attributes I'd like to compare against, and I can very easily write that into a policy document. So that's my Ava group configuration. Now, once I've got all of those resources created, what I do is I just go into Resource Access Manager, and then I create a share. In this case, what I've done is I've actually just shared both of those groups, and I've shared them off to my external account. So let's jump out of this account really quick, and let's take a look at the infrastructure that I've already created, and then how I utilize the Ava group. From the top, as I said, you'll probably want to have some external DNS. So I'm just going to go into Route 53, into my hosted zones, and I've got my zone, myexample.me, where I've got those two endpoints I've created, hr.myexample.me and sales.myexample.me. Now these are both CNAME records, and what they're doing is they're both pointing to the actual dynamic DNS name that was created when I created the endpoints directly in the Ava service, and I'll show that to you in just a second. Once we're out, we've created all of the external zone, DNS that we need. We'll want to create some, as I said, some TLS certificates. And in this case, you can see that I've just set up a wildcard certificate for that entire top-level domain, so that I can go and I can use it on any endpoints I'd like to create. Now, both of those, all that infrastructure being created, I can now just go into my VPC, and then I can come over here to my AWS Verified Access, and I can come to my access endpoints. Now this is where I've created those endpoints so that I can see that my sales endpoint, for instance, is simply set up. I've got a endpoint ID, it's set up as active, it has a security group associated with that, so I can easily constrain and protect that endpoint if I'd like to. And then I can set up, this is a dynamic domain that's set up for it, and then I've gone and I've mapped that directly to mine along with the proper certificate. So now, whenever an end user wants to, they can simply go to sales.myexample.me and they'll be able to authenticate to it. Let me show you what that looks like. So I've just opened up another web browser, and I'm going to go to sales.myexample.me. Now what I have to do is I've got to authenticate into this endpoint. So I'm going to come in as my user account, and then give it the username and the password. I get redirected, and then I'm looking at my sales application. So the proper authentication, I've been able to authenticate incorrectly, and now I have access to the app. However, this is my sales endpoint and a sales user. What about my HR endpoint? If a sales user tried to get into hr.myexample.me, what would happen? And then yes, as you'd expect, if they try to come in as the hr.myexample.me, they're going to get a 403 because they're not authorized by a policy to use this endpoint. Only my sales user is. If I wanted my HR user to come in, I could log out of my sales user, log on as my HR user, and then get access to this endpoint. This was a demonstration and example configuration of AWS Verified Access. Thank you very much.